Okay, so today we're going to cover trig number 3. All right, what is trig short for? Trigonometry. Good. And basically speaking, it's the study of angles. What type of triangle does trig, what is the only type of triangle that trig works with? And I should do a little bit of a disclaimer there and say for the moment, and the answer is just what you said, a 90-degree triangle, okay? Actually, when we get into some other aspects of trig, like the law of sines and cosines, which is technically still trig, that will deal with non-right triangles. So there's some other things to add to it. But for the moment, we're saying right triangles only, okay? All right, so let's go back and review the parts, the names of the sides. So, first off, can you say that this is a right triangle? No. Why not? What do you need to see to know for sure? This little square, this little detail is the definition that now tells you that, even though if I drew it badly or I drew it well, it doesn't matter. It's that little square in the corner that now tells you this is definitely a right triangle because this is a 90-degree angle. Okay. There's 3 sides to the triangle, and there's 2 different names for them. What's one of the names of the sides of the triangle? Leg. Good. How do you know when I'm looking at the 3 of these sides? For example, how do I know that this is the leg or not? Is this side the leg up here? Why? How do you know? Because the 2 legs touch the 90-degree angle. And I always get you to try to do something hokey, but take your hand and go like this, right? Go, right? And I want you to say a triangle has 2 legs like a, and I don't know why, it's kind of dumb, but maybe it's trying to get you to remember there's 2 legs. They're attached to this 90, so this is a leg, and this is a leg. What does that make this side up here? Hypotenuse, good. And I'm going to abbreviate it height. You know it's the hypotenuse several ways. It's not touching the 90, right? It's across from that. And it's across from the largest angle. The 90 degrees has to be the largest angle. As that opens up wider, this side stretches longer, so the hypotenuse is also the longest side of the triangle. Okay, so those aspects make it the hypotenuse. I'm going to abbreviate it height. Now the legs get a little bit more complicated depending on where the reference angle is placed. We use different variables in trig for angles. We use the Greek alphabet letters like alpha, beta. We rarely use gamma. It's just kind of harder to draw gamma, something like that. I don't draw it very often. But we use things like phi, theta. Those are all Greek alphabet letters, and we use them to represent unknown angles. So the complication comes in where we set the reference angle. If we put the reference angle here, let's call this alpha. So all that means is, in the triangle, there's 3 angles. 1, 2, 3. We already know this is 90, so we're not interested in that at the moment. We're either interested in this angle or this one, and we're going to label it by putting a variable in, alpha. Once we label this as the reference angle, these legs take on additional names. What are the additional names? For example, do you know what this leg is called because it's close to the reference angle? Do you know that one? Good, adjacent, okay? And so we're going to call this the adj leg or adjacent leg. So based upon the location of this reference angle, what does that make this leg over here? Opposite, okay? And I'm going to call it op leg. It's the opposite leg. So these words opposite and adjacent in geometry take on slightly different meanings, right? Normally in our language, opposite would mean if I said tall, you would say, what's the opposite of tall? Short, right? Now in geometry, we're using it differently. We're using opposite to mean across from. So if there's a house on this side of the street, and I'm talking to you about explaining the house on the other side of the street, I might say that house is opposite this house, right? It's on the opposite side of the street. So a slightly different use of the word opposite. Adjacent means next to, so 2 houses next to each other on the block, they would be adjacent to each other or next to each other. This becomes important because as this gets rearranged,
hello, beautiful people. Say bye to you guys before I leave. Oh, it's okay. No. I'll see you guys tomorrow. Thank you, sir.
Okay, as this reference angle gets moved around, for example, let's redraw the same triangle. If we redo the same right triangle and we move the reference angle over to here, this is still a leg and a leg. But now where is the adj leg and where's the op leg? Which leg is this one here? Which leg would be this one here? What? I understand why you're saying op leg. I get it, because that's where the other one was, right? But why would you say adjacent? Because now this is the leg close to the reference angle. And this is confusing for us, right? I want to name this an op leg because it's over there. Now all of a sudden this becomes the adj leg because the words adj and op, or adjacent and opposite, are in association to the reference angle. Does this make sense? Do you see how I kind of switched it on you, right? So that makes this leg over here. What's this one called? Now, in this context, this one becomes the op leg because now it's opposite from that reference angle. By switching the location of the reference angle, we have to move those definitions of op and adjacent because they're in relation to which angle we're trying to find. Good enough? Okay. So let's continue on down the road. Before we came up with this, SOH, CAH, and TOA. Sorry, my mind is going blank there for a second. Everybody say so, ka, toa, and put it all together. SOHCAHTOA. This is your secret code for remembering the 3 trig functions we're going to study in this part of the course. Now, it's important you spell these correctly. If you start to rearrange these letters, it can mess up the whole system. And I try to say it a certain way. I try to make this a long O. I try to say so, because I've had students kind of say saw for it, and then it starts to sound like an A there. So I try to get them to say so, ka, and this becomes a long O and a soft A, toa, right? So they can get these in there. So we learned last week that this was sine. We'll put in an alpha because it's a generic variable for an angle. Equals, the O stood for op leg, over height. And that filled the S, the O, and the H. Now we're going to learn ka. So let's move over here for ka. This one's going to be cosine. And we're just going to abbreviate it cos most of the time, COS. Cosine, in fact, let me rewrite it here. COS alpha equals. This is going to stand for adj leg. And this is going to stand for height. All right, so let's see how this works. Let's drop in an example. Let's do 513 and try to find alpha. This one's 5. This one is 13 long, and we're trying to find alpha here. So notice why this gets to be a little bit more complicated. Let's move forward at the moment. What's the name of this side up here that's 13? What is it? Height. This is the height. So when we fill this in, cosine of alpha equals adj leg over height. We say cosine of alpha because we don't know what it is yet, so we leave the alpha in there. We know that you just said the height was 13, so it goes down here. And this becomes the adj leg, because notice it's adjacent to this reference angle. So the 5 goes up here. We move the cosine over and give it the -1 to show it's a reverse cosine. And then we drop in the 5 divided by 13 here. Okay. Pull out your calculators, turn those on, and see if you can give us a value here. We'll say alpha is approximately equal to 67.38. And that's degrees because it's the measurement of this angle right here. Did you get that? Did you get that? Did you get that? Did you get 67.38?
Yeah,
Okay. Did you get it, Maxwell? See if you get it. Before you do that, click clear. Turn your calculator sideways. Good. Did you get the new? There you go. Turn sideways. There. So, click inverse first, then the cosine. See how we now have the -1 on it right there? That's important. And then say 5 divided by 13. Equals? Maybe we're in radian mode. So say clear again, say all clear. Click degree. And now repeat. So say inverse, note back, cosine, good. 5 divided by 13. We always want to be, there's two modes on your calculator. There's rad for radians, which you'll use in algebra 2. We're not going to use that. We're going to use DEG for degree. All right, so in my calculator, it's easy to click one or the other. If you're calculating radians, it won't come out right. Did you get this 67.38? Did you get this one? Okay, so let's do one more. Let's do 17 degrees, 15, and question mark. 17 degrees, 15, and question mark. So here we're using cosine again. Cosine alpha equals the adj leg over height. We do know the angle in this case, so the 17 gets dropped in here, 17 degrees. The adj leg is x because we do not know its length, and the height is 15 here. We're going to do a little bit of algebra, multiply both sides by 15. That'll cross it out here, and we're going to flip sides. X is going to be equal to, 15 times cosine of 17 degrees. X is approximately equal to. Okay, try to type this one in. First, clear out your old stuff. First, click clear, so you got a clear screen for that. You're going to do it backwards. So you're going to do 17 cosine times 15 equals. So how about 14.34? Did anybody else get that? How about 14.34? And so this time you're putting in the 17 first. Oh, good. Thank you. Nice. Now yours is going to be more direct. 17 times cosine. No, that's a cosine. Clear. 17 times. Yeah, it says rad. So go back to degree. Good. There. 17 times. But go back. Shift back the arrows. Shift back to the other menu. Now regular cos. Good. Of 17 degrees. Oh, I'm sorry. 15 times cosine of 17. I'm sorry. 17. There we go. Right there. 14.34. Yes. Get it? Did you get it? Did you get it? Did you get it? Got it. Now, here becomes the one. Here becomes the difficult challenge because now we have two different trig functions. We've got sine and cosine, and we'll have the third one soon. We'll have the tan here, right? We'll have tangent also. The big question now becomes, how do I know which one to use? And it depends on what information you're given in relation to the reference angle. Because the reference angle had a hypotenuse and an adjacent angle, we knew it was cosine. If we had been given this angle, a hypotenuse, and an opposite side, it would have had to have been sine. So just be forewarned, we're coming up on a place where you'll have to discern which trig function to use, and that's a whole new level sort of difficulty I want you to keep in your mind. That's going to be sort of a new challenge, all right? Okay, so with that, go ahead and hit stop, Natalie.